So if you just finished watching my multiplication video, I thought maybe it'd be nice to see an example of actually using the concept of multiplication to apply multiplication in a meaningful way. Not just multiplying numbers, because that's really very simple, but in a meaningful way that allows you to develop multiplication and help you to understand what it is exactly that we're going for when we push into algebra and the type of thinking that multiplication allows us to do. So let's get started. Let's figure out how many squares there are in this shape. Now, we could do it by counting, and that will take forever. But we can, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We can count them up, and we can do it that way. But that is not using the idea of multiplication, which is to look for repeated numbers that we can add together, to look for patterns that we can use to figure this out in a more efficient way, in a more creative way. So instead of counting them all up, we can visually break up this picture in a couple of different ways. So here's one way we can break it up. Okay, so this is the same picture up above, but broken into different pieces. And what's great about this is we can use multiplication to very easily figure out how many squares there are. So this and this is the same, except it's just broken up. So what we can do here is we can say, well, I notice there's there's a row of 5 and there's 5 rows of 5. So this is 25. And I notice that there's another 4, so this is 25 plus 25 plus 25 plus 25. That's 100. And then this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times 3. This one's 27. So 27, and then this one's also 27. So that's going to give us 54. So we have 100 from the corners. These two together make 54. This one's 1, 2, 3 times 1, 2, 3, 4, 5, 6. So 3 times 6, this is 18. This is another 18. So 18 plus 18 is 36. So we've got 100 from the corners plus 54. So that's 154. Let me type this out. So we've got 100 plus 54, and the 54 is the top and the bottom. And the left and the right, those are both 18, so that's going to be plus 36. And then this one's 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, that was 9 up here. So that means this one is 6. So 9 times 6 is 54 again. So this one's plus 54 again. And so we can add these together. 100 plus 54 is 154. Plus 36 is 190. Plus 54, that's 244. Okay, so even though that took us, maybe 30 seconds to a minute, that's way faster than counting up every single square like we would have to do in this one. Now, here's the great thing, right, is that everybody says math is creative. At least all your teachers do, and people say, oh, math is this creative subject. But a lot of times when people tell you how to do a problem, you get stuck thinking that that's the only way to do the problem. So I've shown you this way, but the thing is, this isn't the only way to do the problem. And it really allows for your brain to be creative and pick the way you want to break it up. So you could break it up this way. We got 244. Now here's another way you could break it up. Again, this is the same exact picture. Okay, this is this same one, but now broken up in a different way. And what's great is I didn't change the number of squares, but by visualizing it this way, I'm doing something that might work better for myself. If maybe this one is better for my brain to understand than this one. Or maybe there's another way to break it up, and that's part of the creativity of math, is being able to break this up in different ways and solve these problems in different ways. So here we have 5 times 2, so this is 10. That's 10, that's 20, so 10, 20, 30, 40. So we've got 40 from these larger corners. And then this one's 6. This one is 6 again, so that's 12. And then that's another 6, and that's another 6. So that's a total of 6 times 4, which is 24. And then this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 15 times 12. And if you watched my multiplication video, you know that that's going to be 180. So what's 180 plus 40 plus 24? Well, 180 plus 20 is 200, 244, and you get the same one. You see? So that is the concept of multiplication put to use. Right? This is what multiplication should feel like. This is what multiplication should be understood like. So you're looking for these repeated rows and columns or repeated numbers, and you're trying to find ways to break up these repetitions in a way that is easy for your brain to interpret. And that's what multiplication is all about. I hope that gives you an idea of how you can use multiplication to really go beyond just what the standard algorithm is, because let's be honest, that's something a calculator can do, and we've all got phones now, so it really doesn't make sense to focus on just that part of multiplication. The human part, the part that's creative, the part that's interesting, is this part that I've shown in this video and also in my basic arithmetic, the concept of multiplication video, because that's what multiplication actually is. And if you can understand it that way, it's actually much faster, sometimes even faster than a calculator, just because your brain is such a good pattern recognition machine, and it's way better to do it that way than to to line the numbers up in rows and columns and say, okay, I'm going to multiply this number times this number and then carry the 1 and make sure there's a 0 as a placeholder. Like, that's fine, but there's so much more to it than that. Anyway, I've rambled enough. Have a great day. Talk to you later.